Lesson 1.7, Functions. A relationship between inputs and outputs is called a function. And here's how you will recognize a function. In a function, there is exactly one output y for each input x. There is exactly one output y for each input x. So let's look at these two functions that I've mapped out for you. On this first one, we see that the domain are the input, the x, the range, members of the range are the output y. So each x has to be matched with exactly one y. An x cannot have more than one y matched up to it. So in this case, -3 has only one member of the y that it's matched up with, and that's 5. 0 is matched up with only one y, that's 3. 2 is only matched up with one y, that's 2. And 4 is matched up with one y, that's -1. Therefore, this relation is a function. Now let's look at this second relation, where these are the members of my domain and these are the members of my range. And I'm sorry that this did not come out right, but here we go. So let's determine whether this is a function or not. Well, -2 is matched up with only one member of the range, -3. 0 goes with 6. 3 goes with 9. And 4 goes with 9. Does each member of the domain, is it matched up with exactly one member of the range? And the answer is yes. Each member of the domain has exactly one member of the range. So this is also a function. If you had one member of the domain matched up with, if you had one member of the domain matched up with two members of the range, then it would not be a function. Okay, let's go on. Let's look at this one. 2, 1, 3, -2, 3, 1, and 2, -2. Let's map this one out so that you can see how it looks if it's mapped out. All right, so we're going to place the members of the domain right here. We're going to place the members of the range right here, and then we're going to match them up. So remember that for a mapping, you will list the members of the domain and the range. So for the domain, we have 2 and 3. Those are all the members of my domain. In my x coordinates, I only have 2s and 3s. That's all I have. As far as the range, members of my range, I have 1 and I have -2. So let's map this out. All right, looking at the first ordered pair, 2 goes with 1. Looking at the second ordered pair, 3 goes with -2. Looking at the third ordered pair, 3 goes with 1. And the fourth ordered pair, 4 goes with -2. Notice that both of these domains are matched with more than one range. If even one member of the domain is matched with more than one range, it disqualifies this relation from being a function. So you would say this is not a function. This is not a function. Okay, let's continue. All right, so there are two kinds of functions. There's a continuous function, and then there's a discrete function. First one we'll look at is your discrete function. Well, that's not good. I just won't highlight it. A discrete function, write down the definition. A discrete function is a function whose graph consists of points that are not connected. So, for example, you might have a function that looks like this. With just points, but they don't have any connection. They're just dots on a graph. On the other hand, you might have a continuous function. A continuous function looks like this. This is my x-axis and this is my y-axis. And so the points on the graph are connected. So that would be an example of a continuous function. So that all the points make up a smooth curve or line. When you're viewing a function on a graph, it's very easy to tell whether or not it is a function if you learn how to take the vertical line test. A vertical line test is very simple to do. If your pencil intersects the graph of a relation more than once when drawing a vertical line, then your graph is not a function. So, if you see a graph of a relation and you're asked whether it is a function or not, you can put it through the vertical line test. If there's any place on that graph that you can draw a vertical line and it hits more than one point, then definitely it is not a function. Okay, then we have the nonlinear function. It's a function whose graph is not a straight line. Just like relations, functions can be represented by tables, mappings, equations, and graphs. Okay. All right, so function notation is something that we will be using quite a bit in this lesson, where x represents the elements of the domain and f of x represents the elements of the range. So, for an equation, you have y equals 3x minus 8. That equation in function notation looks like this. F of x equals 3x minus 8. Y is the function of x. Those two are the same. Okay, let's look at these exercises where we will be finding the value of each function. So, for f of x is equal to 2x minus 3, find the value of the function of 1. We want to find f of 1. So if f of x is 2x minus 3, wherever there is an x, we're going to substitute a 1. So f of 1 would be, instead of 2 times x, it would be 2 times 1 minus 3. And we're going to solve using order of operations. 2 times 1 is 2, minus 3 is negative 1. So f of 1 is negative 1. Okay, again, we're going to use the same exact function rule, and I'll write it down on the top hand corner here. Okay, so f of x equals 2x minus 3, and we're going to find 6 minus f of 5. So what we will do is we will simply say, well, 6 minus the function of 5 means 6 minus 2 times 5 minus 3. And then we follow order of operations. So the first thing we have to do is negative 2 times 5, that's negative 10 minus 3. 6 minus 10 is negative 4 minus 3 is negative 7. Okay, let's erase what you just did and let's take a look at this all over again. 6 minus the function of 5. First, let's find out what the function of 5 is. Function of 5 would be 2 times 5 minus 3. So 2 times 5 is 10 minus 3, which is 7. So 6 minus the function of 5 would be 6 minus 7, which is negative 1, and that's the right way to do it. I had a little issue with my order of operations previously. So if your function notation is part of another expression, find that first and then substitute. Okay? All right, so 3 and 4, try on your own. We're using the same exact function rule. Okay, where f of x equals 2x minus 3. So go ahead and do 3 and 4. Pause the video now and we'll get back to it and check your answer. Okay, for number 3, the function of negative 2 is negative 7. Check your work. Make sure that it makes sense. And then for number 4, first I found the function of negative 1, which is negative 5, and then I found the function of positive 2, which is 1, and then I added. So negative 5 plus 1 is negative 4. And so that's the answer for number 4. Okay. All right, let's continue. For some independent practice, I want to do one of these with you. Actually, I'm going to let you do 1, 2, and 3, but I'm going to do 4, 5, and 6 for you, just to show you the vertical line test. Look at number 4 with me. On number 4, there are various places on this that I can draw a vertical line and hit more than one point. So that means this is not a function. Okay, we're being asked whether it's a function or not. Number 5 is a vertical line, so if I draw a vertical line, I'm hitting every single point on the function. So obviously, this is not a function either. Not a function. For number 6, no matter where I draw a vertical line, I only hit one point on my function. So this is a function. So go ahead and do number 1 and 2 on your own. Number 3 is a mapping. You need to determine whether it's a function or not. And then 7, 8, and 9 you're going to do also. 7, 8, and 9 you can either map it or you can graph it to determine whether or not it's a function. Okay, for this worksheet, I want you to do number 1, number 4, 11, and 14. And what you're going to do here is you're going to find the value of each function. Now, the function of x equals 2x minus 4. That's your function rule. And g of x equals x squared minus 4x. And it works the same way whether you have g or f. Okay? So go ahead and work on 1, 4, 11, and 14. Remember to jot down any questions you have. We will continue practicing this skill tomorrow. Remember that a pop quiz is possible, so be ready, have your notes, have everything down. God bless you. Have a great night.